Okay, what you see in front of you here is the ISP software for the Delta, and I'm going to be going through data registers and math functions first of all with the Delta because it's a lot easier for me to teach from and for you to see, and then we'll get into the Schneider that I have, and you can see the demonstrations. But uh, right here, what you have is your basic on delay timer. Right, if you were to get a printout of what's going on in the PLC that this is programs in, you would notice we have a timer, TMR, and this timer is T0 right there. So that's timer 0, and it is set to 30. Well, what's 30? Well, in Delta, this is 3/10 of a second, so this is really 3 seconds. So you'd want to know what that value stands for. But basically, this is a 3-second timer. Our input, whatever the input is, whether it's a photo sensor, whatever, input X0. We'll start the timer, and once it counts down to 3 seconds, it closes this contact, and you'll notice this contact T0 is the same exact T0 as this timer, so you know that this is associated with the timer. It gets closed, and we have an output, right? That's your basic on delay timer, and I'll show you that here in a second, but notice this. These are the same exact timer, but this says D0. Well, so what's the value? I mean, this is timer T1, of course, the values are changed, but it's all the same. Timer T0 is set for 3 seconds, but timer T1 is set for D0? That's weird. Well, what that D0 is a data register. Anytime you see D0, D1, D2, D3, those are just data registers. Basically what that is a placeholder so that you can do inputs for functions that set this D0 to 20/10 of a second or 2 seconds. This move function sets data register D0 to 2 seconds. This input, now these inputs would be like push buttons that an operator sets. Maybe they want to increase the on delay or decrease or whatever. So if they push this push button, X, that goes to input 3, basically the value of D0 goes to 4 seconds. If they push the push button that goes to input X4, the value of D0 goes to 6 seconds. So this move function is just a way to set the data register, okay? I'm going to put this online in the simulator. Unfortunately, I don't have a Delta PLC, or I would show you a little bit better. But so now we're on simulator mode, right? And let's just start with the original timer set for 3 seconds. You saw this in a couple of videos ago. Starts the timer. Once it hits 3 seconds, you get an output, and that's just set to 3 seconds. You can't really change it, right? So that's why sometimes if you want to be able to change something, you use this data register here. Rather than putting 30, I put D0, and when I went into online mode, it just went for the last value that it had. That's why I had it offline, is to show you what you're going to see. If you get a printout of what's going on in the PLC, you'll see that D0. You won't see that it equals anything. Well, this is the program happening. So let's see, our timer right now is set for 6 seconds, and that's just simply because the last one I had pushed was this move function for 6 seconds, but it just kind of goes with the last one we pushed. So let's push this one for 2 seconds. So I push a push button for the move value of D0 to be 2 seconds, and you can see the value of D0 now equals 2. And like I say, I pushed it in. Now I force it off. That's me pushing it in and pushing it off. And my value stays at 2 seconds. So now my timer value, see right here, is 2 seconds. So when I get my input, after it counts to 2 seconds, I'll get my output, right? And let's see here. Let's just go here. Force on. So now I push this one on, off, and the last one I push now is 6 seconds. So my value D0 is 6. And anywhere you see D0, you'll notice it just changes that value. It lets you know wherever the D0 is what the value is. And where that really is important is here. Now my timer value is 6 seconds. So that was the last one I pushed. So we'll force this one on, and it'll count to 6 seconds and then give an output. So that's a little bit longer of an on delay. right? And of course, you know, if we do the one for 4 seconds, you can imagine what'll happen. But for good measures, I'll just show every one of them. So now the last one, the last input for move function was for 4 seconds. So we set our D0 value for 4 seconds. So this is kind of in between the 2 and 6 seconds. So, you know, it's just kind of a mid-range on delay, I guess, for these ranges. So that's pretty much it on the move function with the timers. So, one other thing. What if I were to push them all on at the same time? This is really why you want to have a momentary on-off, because if you had like a toggle on or off, you could have multiple of these move functions being triggered at the same time. So, like, say we turn on our 6 second one. Well, my D0 is 6 seconds, but if we forget it's on and we try to move our value to 4 seconds with this still being on, well, shoot, it doesn't move because it just goes with the highest value. So I could turn on every one of these move functions and it's still going to be 60 because that's the highest value. Now, if I were to turn this one off, then the highest value now that's on is 40. So, you know, it kind of gets wonky if you have it on toggle switches. So that's why you want push buttons. And, you know, the last one you pushed is the one that it goes with, and that just makes life a little bit simpler. But that was your basic on delay timer with a data register. Next, we're going to do an off delay timer with the data register. Okay, right here what we have is a basic off delay timer. You'll notice the last timer, if you need to rewind it, you can look, basically looks the same. The only difference is we have a normally closed contact here. So when we hit our input X0, you know, when the sensor senses whatever that input is, it'll start my timer. But my timer, you know, that whereas the on delay timer was a normally open contact and it closes when it reaches its set time, this is closed and it stays closed until the timer reaches its set time, then it opens. So this is an off delay timer. Basically, the only real difference was that contact for T0 here. See, this is timer T0. The contact is normally closed. So this is an off delay timer. You'll notice I have D0. That's my data register. And you will notice, just like before, I have my move functions of 2, 4, and 6. And I bet you can understand exactly how this is going to work. So I'm probably going to fast forward this a little bit and just kind of go online and show you. So basically, my data register 0 hasn't been set yet. So I'll use my middle move function. Force it on. Force it off, just like the push button that we talked about before. You want these things on a push button. So now my data register value is 4 seconds. So this is an off delay timer, right? When I get my input, the output will turn on and then it will turn off after the time. See, my output is on. And once my time hits 40, it turned off. So that's your off delay timer with the data registers. You probably don't need me to bore you with showing you all of them, because I showed you the same thing with the on delay timer. I just showed it as an off delay timer too, to give you a little bit more exposure to that. I'm going to pause this video and then we're going to load some counters and we're going to look at the data register with the move function and counters. You know what? I lied. We're not going to do counters. We're actually going to do the data register with comparators. Before, I showed you the timer, and it did not have a set time like this one does. It had the data register, right? Well, what if we have a set time for our timer, but we want to change the values of our comparators, right? Well, down here I have some comparators, and you'll notice I have a D0 and a D1. These are my data registers, right? And basically what this program means is when my input X0 will start this timer, and this timer will go for 5 seconds, and this timer actually at the end of 5 seconds will reset itself. So this is basically a timer that just kind of will keep cycling, right? It just, after 5 seconds resets itself. So what we have, to be able to do anything, we just have these comparators, right? When my value of my timer T0, see timer T0 up here, and this is timer T0, when my value of timer T0 is greater than whatever my data register is set, and less than whatever my other data register is set for, we'll get an output. Once again, I have my inputs for my move functions. My X1 will set my lower threshold for 3 seconds, and for 2 seconds, my X1 will set my lower threshold for 2 seconds and my upper threshold for 3 seconds. My input X2 will set my lower threshold for a half a second or 4.5 seconds. So basically, what this means is, obviously this is 1 second between my greater than and less than. So let's see here, I'm going to put this online. One second, I need to load this, so I'm going to pause it and then we'll be back. Sorry about that. I had compiled it, but I hadn't downloaded it. So basically, here's our comparators right here, right? Remember, our timer is set for 5 seconds and it resets, but we want our comparators to turn on an output. So if I, let's see here, if I go online, of course, if I force this on and force it back off to simulate the push button, you notice my D0 value went to 2 seconds and my D1 value went to 3 seconds. So now this is a functional timer where, it goes for 5 seconds, but when the value is in between 2 and 3, we have an output. So we'll kind of look at this one real quickly. So I turn my timer on and you'll notice it'll go up to 5 and then it'll kind of keep resetting. See how it just keeps resetting? And what causes this blink is when my value is above, is greater than 20 and less than 30. So it blinks for 1 second. Now, what if I wanted to change that? Well, that's exactly what a data register is for. So let's hit this data register. Let's choose this one, or choose this move function. So now you'll notice my lower threshold is a half a second and my upper threshold is 4.5 seconds. So right here, my lower threshold, when the time is less than 5/10 of a second, or when it's greater than 5/10 of a second or a half a second, this will allow the output until it gets above 4.5 seconds. So basically my output will be on for longer in the cycle, right? So turn that on and you'll notice my green light stays on a lot longer. Well, that's because it's got more time in between a half a second and 4.5 seconds. So once again, that's just the data register when I didn't really associate it with the timer, but I associate it with the comparators. Pretty much anywhere that you have a value you're looking for, you can use a data register as a placeholder and move functions to kind of set those to where you can choose different thresholds. Okay, now we're going to pause it and get into counters.